Okay, we're going to start on topic 7.4, dividing radical expressions. And another key word we'll use later is rationalizing. But as we look at these fractions that are in radical form, what do? And the instructions, by the way, are they're only looking for the positive values. Well, you could divide that into the square root of 81 over the square root of 49. So this would become 9 over 7. Now I'm going to sort of skip this step, keeping in mind that's what I'm doing. So in this case, let me be sure I copied it down correctly. Number 4, nope, there's a 3 there. Because both of these are perfect cubes. So the cube root of 125 is 5, and the cube root of 64 is 4. Now for number 5, you have the square root of this. Now we know our bottom is a perfect square. That's going to be q to the 5th. You're just taking this index number and dividing it into the exponent. We know this is a perfect square, and that'll be 4. And then mentally, we're going to divide this p to the 5th into a perfect square, and then a p left over. So the square root of p to the 4th is p to the 2nd, and then you're left with the square root of p. And again, down here, as we look at this, this is the third root. This is a perfect third, and that will be 3y. And the 1000 is a perfect cube as well. That's 10. And then we're going to divide that x to the 7th into x to the 6th, and then an x, as we did in a previous lesson. Divide the 6 by 3, we get x to the 2nd, and then the cube root of x. In number 4, again, something similar. This is a perfect fourth. This is going to be a to the 2nd. Now the b, remember that's going to be b to the 4th, b to the 3rd. So you'll take a b out of there, and then what's left under the radical is b to the 3rd. And down here, again, you're going to be able to take out a 12. C to the 12th is a perfect fourth, and you're left with c to the 2nd. So this will be c to the 3rd, the 4th root of c squared. And then you're doing similar things down here. In our numerator, we can take out an m, and we're left with a m under the radical sign. Let me just do that for you. That'll be m to the 6th, m. So the 6th root of m to the 6th is m, and we're left with 1 under the radical sign. This is a perfect 6th power, so that becomes n. And then here we're going to go p to the 18th, p to the 2nd. 18 is a perfect 6th power, so that comes out as p to the 3rd, and then the 6th root of p squared. Now they're changing things a little bit. Instead of having it in this form, they have it in this form. Well, what we can do is just take away the single radical sign and extend that radical sign to everything. Now we can actually do division. 5 goes into there once, 5 goes into there 6 times. X goes into there once, X goes into there once, so this becomes the square root of 6. Again, instead of listing it separately, we're putting it under a common radical sign, and we're allowed to do the division then, as we see in example 10. So mentally, we could just go 5 goes into there once, 5 goes into there 10 times, and then you're left with the cube root of 10. You could, if you like, write it again under a common radical sign and do the canceling, or if you could do it mentally, that's fine. 2 goes into there once, 3 times, take out one of these, so this becomes the 4th. And then we take the square root of a to the 4th, which will be a to the 2nd. And what's left under the radical sign is the square root of 3b. Okay, this was, again, some sort of easy stuff, but you may have to spend a little more time looking at it. Okay, continuing. Now, this was the original problem, and what I did is I took the square root of 81 out, and I made it a 9, and then left this under the radical sign. And now, what I'm going to do is this. 3 goes into 3 once, 3 goes into 9 3 times. So I now have 3, the square root of x, y, z, over the square root of 3. Now, they didn't ask us to do this, but in order to solve this, we're going to have to do something we're going to start in a few moments, which is called rationalizing the denominator. And we have to rationalize this denominator by multiplying it by the square root of 3. And we do the top also by the square root of 3. Now notice, the square root of 3 divided by the square root of 3 is 1, and we are allowed to multiply anything by 1 without changing its value. Well, an interesting thing happens then. This then becomes the square root, well, the 3 is there, the square root of 3x, y, z, and the square root of 3 times the square root of 3 becomes the square root of 9, which is 3. And now these last 3's cancel out, and that's the final answer. But it's difficult, as I see it, to get that final answer without rationalizing this denominator that we don't start until a little later in this lesson. But that's how I did it. Also in number 13, as we look at it, it was under 2 radical signs. I put it under a common radical sign. So now we can cancel out the 5 with the 80, and that gives me a 16. I could bring the negative 2p, or p to the negative 2 up, and this will become a positive 5, and this disappears. And I bring the q to the 2nd up, that subtracts from that, and this becomes a 3. So now we have this. Well, the 4th root of 16 is 2, and p to the 5th, I can change p to the 4th p, so I take out one of those, which is p. p to the 4th becomes a p outside the radical sign, and then under the radical sign, with the index number 4, I have a p and a q to the third. And that's your answer, and that's simplified. All right, this one's over here is kind of interesting because I don't know if you see what's going on there. This is the difference of perfect cubes, which will factor into x minus 1, and then x squared plus x plus 1. But notice now you have an x squared minus 1 and an x squared minus 1 that cancel out. So your final answer for number 14 is just the cube root of this up here, x squared plus x plus 1. So some interesting things going on, but hopefully as you reflect on what you've been doing. Now, it's at number 15, and from now on, they want us to rationalize the denominator. Right now, as we look at this denominator, it has the square root of 2, which is an irrational number. But if you multiply the square root of 2 by the square root of 2, and the numerator by the square root of 2, remember, this is a 1, in the form of the square root of 2 over the square root of 2. You're allowed to do that. But now this becomes the square root of 4. The square root of 4 is 2, and 2 times 5 is 10. So where this denominator used to be irrational, now it's rational. We have rationalized, in this case, the denominator. And we still have the 3 on top, and we go square root of 7 times the square root of 2 is the square root of 14. Okay? Now, for number 16, as we look at it, we want to rationalize this denominator. But notice the index number is 3. So we have to make this a perfect cube. So to do so, we're going to have to multiply it by the cube root of 9t squared. T times t to the second is t to the third. It's now a perfect cube. 3 times 9 is 27, which is a perfect cube. So our denominator over here now will become 3t. Because this is 27t cubed. The cube root of that is 3t. And I have to do the numerator as well. So this is 2 times 9 is 18. The cube root of 18 st squared. And that's the answer. I have rationalized the denominator. And here the same applies. What do I have to multiply this by to make it a perfect cube? Well, this is x to the first, so I have to multiply it by x to the second. This is y to the second, multiply that, y to the first. And whatever I do to the denominator, I do to the numerator. And what do we get out of this? Well, our bottom becomes x to the third, y to the third, so it's just xy. And our numerator becomes the third root, kind of ran out of room there, 10 x squared y. All right. Trying to keep the tapes a little shorter. I noticed they were getting a little long. Again, if you want to go back and watch them again, you're welcome to do that. Okay, as we wind up 7.4, 18, 19, 20, 21, 22, in black are the original problems. Here they want us to rationalize the denominator of 18, but then from 19 on, they want us to rationalize the numerator. So, again, we want to go over strategy here. As we see 50x squared y, I see in 50 a perfect square factor of 25 times 2. And x squared is a perfect square, so I put that under a radical sign. Now again, you may not write this step in red. You may be able to mentally go ahead and do it. So the square root of 25 is 5. The square root of x squared is x. And then for 8, we have 4 times 2. Square root of 4 is 2, the square root of 2. So this is sort of what I have as I prepare to rationalize then this denominator. So I'm going to multiply this by itself. So that will eventually become 4y squared. 4 squared, the square root of 4 is 2. So I have a 2 that comes out of here, a y that comes out of here. So 2 times 5 is 10. There's my x, and there's my y, without the radical sign. And then I multiply my top by the same thing, and I get the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. So there's where I get that extra 2. And then what's left under the radical sign now is 2. I'm sorry, not a 2. The 2 is out of there. Just the y. So now, this is a 4, and this is a 10. Can you see, I can take a 2 out of the 10 and get 5, take a 2 out of the 4 and get 2, so my final answer for all of this one will be 2, the square root of y, over 5xy. And again, if I were going to try to write this and make it short, it takes a long time, but there's all the work. You can pause the tape, take a look at it, but there's a lot of stuff going on there. Okay, here they change what they're looking for. Instead of rationalizing the denominator, they want to rationalize the numerator. So I have square root of 15 times the square root of 15 will be 15. So I had to multiply this by the square root of 15 also. But is there a perfect square in there? So what I did is I went 35 is 5 times 7. 15 is 5 times 3. So you see I have 25 there, and the square root of 25 I pull out as the 5. And then what's left under the radical sign is 21. So this is what I have. But now you'll notice I could cancel 1 out of there, 3 out of there. So my final answer here is 3, the square root of 21. 20 is sort of easy to do. There we have it set up. Rationalizing the numerator, so square root of 11 times the square root of 11 gives you an 11. And the 5 goes along. Then we have our denominator that we have to multiply by the square root of 11. This just becomes my 33, and the 4 goes along. But remember, I'm not finished here. The final answer of this will be 55 over 4, the square root of 33. And what I was doing here when I multiplied the 35 times 15, I'm showing you how if you put it into its prime factors, you can see if there's perfect squares there already, and there was a 25. It's 25 times 21 is what the product of that would be. All right, now for 21, again, we're rationalizing the numerator, and this is a 5, but notice the index number. The index number is a 3. So we have to make this into a perfect cube. Well, we're not going to multiply it by 5. That would just be a perfect square. We choose 25, which then makes it 125. And the cube root of 125 is 5. And then 7 times 25 is 175. And there are no perfect cubes in there, so that's the answer. And for our last example, we had this originally, and again we're rationalizing the numerator, and it is to the 3rd power. And we had this, so to make 6 into a perfect cube, I have to multiply it by 36. So 6 times 6 times 6, the cube root of that is 6. Then I had x to the 7th. Well, to make that into a perfect cube, I had to multiply it by x to the 2nd, which made this x to the 9th, a multiple of 3. So I took the cube root of that, and that's where I got x to the 3rd. Now I just multiply my denominator. 5 times 36 is 180. Y times x squared is x squared y. I put them in order. We're allowed to change the order of it. And then this winds up section 7.4. We'll be going on to 7.5. And good luck. And again, try to keep up with your homework, your practice, and your quiz me's. That's the best way, and let your instructor know if you need help on something.